Hello, my name is Bradley Schooley, and this is part 4 of the optimization series, where I'll show you how our fictional company, Acme Financial Data Services, can take their existing Windows file servers and optimize them with Amazon FSx. So let's talk about the optimization story so far. In part 3, we talked about how SQL Server was optimized on AWS. This was done in two ways. One is that we used Amazon FSx continuously available shares to store our databases and logs, taking away the management layer of the storage subsystem. Additionally, we use NVMe instance storage for the temporary database and buffer pool extensions so that we could reduce our compute size for the instances. In this session, we'll look at how Acme Financial Data Services, or AFDS for short, can optimize their file servers on AWS. Doing so will decrease management and maintenance tasks, improve reliability and performance, have broad compatibility with existing workloads, along with migration with little downtime, and what options are available to optimize cost. Let's recap on the current architecture. Currently, Acme Financial Data Services has two file servers, one in each availability zone, serving out its shares. Additionally, it has a distributed file system namespaces server, creating a single location for users to access those shares. These file servers are currently standalone, meaning they lack high availability and are single points of failure. This complicates maintenance tasks such as patching, by causing outage windows. So let's discuss how we can optimize this using Amazon FSx for Windows File Server. We can reduce maintenance and management because AWS manages the servers, the patching, and any underlying host issues and recovery. Customers simply manage the file shares through familiar tooling. Additionally, because this is a native Windows file server underneath, it has things like native Active Directory integration so that you can preserve your ACL structure. It is an NTFS-based file system. It supports the native SMB 2.0 to 3.11 protocols. Additionally, it crucially has support for distributed file system namespaces, which Acme currently uses in its setup. And we have cost optimization options through the use of hard drive-based storage, deduplication, user storage quotas, and are able to scale the file system based off of usage. Having a place to put the data is only one piece of the puzzle. We also need a way to migrate it. This is where AWS DataSync comes into play. AWS DataSync can migrate all of the existing data on the two available servers while preserving file structures and permissions. In Acme's case, it is already hosted on EC2, so we'll be able to deploy our DataSync agent as an EC2 instance. But be aware there are other deployment types for VMware, Hyper-V, and KVM. DataSync also allows for keeping any deltas up to sync after the initial sync, which allows you for more flexibility on when you want to cut over. In the above diagram, our AWS DataSync agent is connected to our two existing shares via the SMB 3.0 protocol. The agent then replicates to the AWS DataSync endpoint via a TLS encrypted connection, and then moves that data over to matching shares in our FSx file system. Distributed File System Namespaces, or DFSN for short, is used in Acme's current deployment to consolidate their existing shares under one name. Currently, there is only one server in one availability zone. As part of our optimization, we'll add a second node to another availability zone for high availability. FSx supports the use of DFS namespaces, which we'll use when we migrate the existing folder targets after the data is synchronized from the source file systems. This will ensure a more seamless migration and minimal downtime. Let's put all these pieces together and look at what the finalized architecture will be. FSx will now host the replicated data across 2 availability zones and manage the underlying instances for you. From an HA standpoint, we've also added another DFS namespace node so that it is not a single point of failure. A namespace instance does not require many resources, so we'll be able to use a small burstable T3 instance to keep our costs in check. Additionally, we'll eliminate our 2 file servers, reducing our EC2 compute footprint. SMB clients, like Windows machines, will continue to access the shares by the same names that they did before. Now that we have a highly available FSx system deployed, administrators will need a way to manage the file shares themselves. FSx allows admins to use familiar tools like the FS Management Snap-in, which will allow you to add, modify shares, permissions, and view open sessions and files. For more advanced capabilities, FSx also provides a PowerShell endpoint that lets you perform the actions above as well as enable and modify features like data duplication, user quotas, and shadow copies. I will demonstrate you in the upcoming demo how exactly to use these tools with Amazon FSx. I will now switch over to the demo where I will show you how Acme Financial Data Services is able to deploy FSx, manage the shares, and migrate those existing shares with minimal downtime. By the end of this demo, we'll have completed the solution shown in the presentation from deploying the FSx file system all the way to the finalized user experience after migration. Let's start out by analyzing a following common deployment pattern for Windows file servers. I have a user who's going to log into their Amazon Workspaces account, which is joined to the afds.com domain. At login, the user is automatically going to get 2 shares mapped to their account via group policy. One, a user share that is directly associated with this user only, and the second, a development share that is based off of group membership. These shares are hosted on the 2 separate file servers and use a DFS namespace to logically group them. If this user attempts to go to the DFS namespace name, which is the domain name / shares, and then the 2 individually shared shares from the existing file systems, dev share and user share. Now, it is crucial when we migrate that everything within these shares is maintained as is. So the structure and the permissions, and from the user perspective, the drive mapping that they currently use. But before that, we need to first deploy a new FSx file system. At the AWS Management Console, we need to go and search for FSx. Once at FSx, we can say Create File System, Amazon FSx for Windows File Server. Now we need to put in some details. We need to give the file system a name, so we'll name it after our domain. We need to choose a deployment type. There are 2 different deployment types, multiple availability zone and single availability zone. For this particular deployment, we're going to choose multiple availability zones to meet Acme Financial Data Services high availability requirements. Next, we need to choose a storage type. This requires some knowledge about the existing file system's requirements. Luckily, Acme has provided those for us. We can see in the file system's requirements that were provided to us that we need at least 1.5 terabytes of storage, an average throughput requirement of 24 megabytes per second, and a peak throughput requirement of 150 megabytes per second. We will use this data to guide our decisions and what we choose for FSx. Now that we know the storage requirements, let's go through how we choose what to pick. SSD has very high performance characteristics with a baseline of 750 megabytes per second per terabyte of storage, and hard drive provides a 12 megabytes per second baseline with 80 megabytes per second burst per terabyte, but at a significant cost reduction. Given this information, we know that a 2 terabyte hard drive volume will meet the requirements of 24 megabytes per second baseline and 150 megabytes per second burst. The second performance calculation is the independent throughput characteristic, which determines our baseline and burst performance to the in-memory cache, as well as throughput from the file server to the underlying storage type we choose. The FSx console will automatically recommend throughput based off the storage type and size of storage that you pick. In this case, 32 megabytes per second throughput would exceed our performance requirements for both network and disk. So now let's go to the FSx console and show you how this works. Back at the FSx console, we'll now choose hard drive, 2048 gigabytes of storage. And you'll see here that the FSx console automatically provided the 32 megabytes of throughput that we need. Now we need to pick a deployment VPC, subnets, and security groups to apply to FSx. Routing has already been set up to allow clients to connect to the appropriate subnet. The security group for the FSx nodes will need to allow ports for communication with AD, DNS, SMB clients, and finally a private port for management. You can find port requirements in the FSx documentation. Now, we need to choose an Active Directory deployment to join our FSx instances to. In our case, AFDS has their own self-managed Microsoft Active Directory running on EC2, but you can optionally choose AWS Managed Microsoft AD instead. You will need to provide at minimum the Active Directory domain name, a DNS server IP address that can resolve the domain controllers, a service account that has delegated privileges to join the FSx file systems to the domain and register SPNs. Optionally, you may also delegate access to a specific organizational unit. And you may also delegate who the administrators of the file system will be by choosing a group within your Active Directory. By default, the group is the domain admins. For encryption, you may either choose the existing managed key for FSx or create your own. There are additional options down here that you do not have to fill out at this time. We will be looking into DNS aliases later, backup and maintenance as well. Now we review all of the options that we've chosen and simply go down to the bottom and say Create File System. For the purposes of this demo, this file system has already been created. We can see here that we have the file system, its status is available, which means we are actually able to connect to it now. But first, we need to get its DNS name. Here in the Network and Security tab, you can see the DNS name as well as the Windows Remote PowerShell endpoint, which we will use later. For now, we're just going to copy this DNS name and connect to it from an administrative instance. I am now on an Amazon Workspaces instance that is joined to the domain and has the file system management tools installed. Let's just first see if we can connect to the share via its UNC path. Here we can see a couple of shares that I've already created. Now let's connect to the file system via familiar FS Management Snap-in tool. This is done the same way as if you were connecting to a file server remotely from any management server. Under our shares, we can see the exact two share names that I just showed you via the File Explorer. As for managing the file system, it can be done through the snap-in, or more advanced management can be done through PowerShell. Let's try and create a share. So first, we need to connect to the instance and create a folder to share from. So you would simply enter the UNC path of the file system and then go to D $, which is the default share or the D drive share. Here we could create a folder and call it test, and then come back here and go through the new share wizard as if you were sharing from any other Windows file server. Permissions are managed just like you would on any other file share as well, with Windows permission ACLing. So you can see here, now I have this test share, and if I were to go to the root, we would see test. Now, what if we want to do these management activities from the PowerShell endpoint? Well, first, let's go and grab the Windows Remote PowerShell endpoint name, which is separate from the file system name that you access the shares through. Now, we'll go back to our instance, and to make it easier, we are just going to enter in that PowerShell name and the file system name as variables. Now, let's create a new directory from PowerShell. Next, we need to actually connect to our instance, which is done through the enter ps session command. This establishes a remote PowerShell connections to the instance where it will expose a variety of commands for us. One of those commands is new FSx SMB share, and that's what we're going to use to create a share from PowerShell. So let's just run that command and see what happens. Let's call the name PowerShell test and press enter. It is going to prompt us for credentials for an FSx administrator. So I have a service account that is an administrator. And then you can see there that it has created our PowerShell test share with a path of D PowerShell test. If I run get FSx SMB share, it will return all shares that are created on the file system. So you can see the PowerShell test one there, and you can see the test one we created earlier. So that is just two ways to create shares. But what about some other capabilities? For example, FSx has the ability to run deduplication tasks to save on storage. To do so, you need to enable it first. You do this through the enable FSx dedupe command. This is only available from PowerShell. There we can see that it has enabled it with the default settings. Now that I've enabled FSx dedupe, we can check its status by running get FSx dedupe status. Here we'll see how many files it found that are in policy, as you can, for example, exclude file types. Additionally, it will show you how many out of those files that are in policy have been optimized so far. So you can see here 29 files. Then it will show you the optimized file savings rate, which is a percentage, and then the actual saved space that has been achieved so far. Other tasks that you might want to perform from an optimization standpoint for FSx is to enable user quotas. User quotas will prevent users from consuming more space than what you set. So for example, I want to set my FSx user quotas to 2 gigabytes with a warning of 1 gigabyte. So to do so, I would run the enable FSx user quotas command. Here, I'm just going to paste it. Enable FSx user quotas. We're going to track in the file system a default limit of 2 gigabytes and a default warning limit of 1 gigabyte. The file sizes are in bytes. Now that it's been enabled, I can check on the settings, get FSx user quota settings. You can see here the default warning and default limits that I've set. Additionally, you can always change these afterwards with set FSx user quotas. Another common task that you might want to do is enable FSx shadow copies. So shadow copies enable users to perform item level restoration. Now, FSx shadow copies are not enabled by default. To enable the FSx shadow copy, we first have to set the default storage limit. So shadow copies will take up storage, and you need to set either a percentage or a maximum size amount. So we'll say set shadow storage, and then we'll just choose the default here. Additionally, we could say something like set FSx storage and then a max size percentage. So we know that we have some overhead in the disk. So let's just say we'll set it to 20% of the total disk size. Here you can see the amount has changed from the default, which is 10%. There are several other tasks you can perform via PowerShell as well, such as viewing any open SMB sessions. Currently it is showing none open, so we'll just go ahead and connect to one. Now if we rerun this command, we can see the new connection. You can also end an SMB session, such as in the case of something being hung. You can check the status of files that are opened by clients, and then close any sessions that have a file opened. For example, in issues where there's a file being locked incorrectly. We can also view things like the SMB server configuration. So if we do get FSx SMB server configuration, we can see the status of encryption. So our data, our TLS is enabled right now, and you can allow or disallow clients that do not support encryption, which essentially just restricts SMB clients to 3.0 and above. Now that we've looked at some of the configurations you can do via the snap-in and some advanced configuration that you can do through PowerShell, we're going to hop back to the console and show some of the other options that you have for configuring and monitoring. In the FSx console, after you select the file system, you have these tabs here which allow you to do things like set up monitoring via CloudWatch alarms, view some existing metrics. Here we can see free storage capacity, and free storage capacity is actually increased due to the deduplication jobs that are running in the background, throughput, IOPS, And you can view these on different timescales. And of course, you can always add them to a CloudWatch dashboard. From the Administration tab, this is where we set our weekly maintenance windows. Because this is a multiple availability zone deployment, during maintenance, the primary node will fail over to our secondary node, and that will get updated, and then we'll fail back and update the secondary node. You can choose these maintenance windows based off of your own preference. So for example, I could choose Friday at 11:30 UTC if I wanted to. For backups, you can set automatic daily backups up to a maximum of 90 days for retention. You can view all of your existing backups here. And if you wanted to, you can select and say restore backup and choose a new file system in which to restore to. Additionally, you can update storage or throughput capacity. These are tracked in the Updates tab. Here, I've already performed an update to show you what it looks like, where I changed the throughput capacity from 32 megabytes per second to 64 megabytes per second. Now that we've gone through some of the configuration options, we need to look at how we can transfer the data from our existing file servers to the new FSx file system. This is going to be done through something called AWS Data Sync. AWS Data Sync is a data transfer service that simplifies, automates, and accelerates the moving of data between two file systems. It's going to use the SMB protocol to attach to our existing file system and then migrate it directly to our FSx file system while preserving all of file system metadata like ownership, ACLs, and timestamps. So let's just go search for data sync. And there's a few components to understand here. First, there's the agent. So the agent is our EC2 instance that acts as the go-between between the data sync endpoint and our SMB shares that are located on our existing file servers. So these agents can be deployed as EC2, VMware, Hyper-V, or KVM VMs. Next, we have our locations. Our locations are simply the source and destination endpoints for where we want to replicate our data. So in my case, I have 4 locations. One source for each one of the shares that exist on my current file servers. So you can see here, I have a host of AFDS FS1 and the share path of /users with a type of SMB, and a second one of my shares with another SMB type. And then our destinations, which in this case will be our FSx file system. When data sync replicates our data, it will automatically recreate the structure underneath these shares for us. And then finally, we have our tasks. Our tasks are what actually set up and perform the replication. So you can choose an existing location for your source. In my case, I could say like my AFDS FS1 server /users. I could choose an existing location again for my destination. In this case, it'll be FSx, and I will choose the same matching share on that side. Now that there's a source and destination configured, there's some additional options to be aware of, such as whether you want to verify data during transfer or after transfer, whether you want to overwrite files in the destination from files from the source. So for example, if the file changes at the source, it can then overwrite the data in the destination, or whether you want to keep deleted files on the destination if someone deletes it from the source. You can set bandwidth limits to prevent oversaturation of your network. You can filter on specific file types or folders. You can also set up a schedule. This allows us to keep the data between the source and the destination in sync every time the task runs. So for example, every hour we could check for any changes, and then depending on the options you chose above, overwrite any differences between the source and destination file. For now, I've actually already created these tasks and completed them, which has replicated all of the data from our source servers, which are currently being used by users, to our destination on FSx. So let's go and look and compare what is at the source and at the destination. I'm back on my Amazon workspaces with my fictional user, Aaron Russell, who has access, as shown before, to his own personal user share and the developer share. Now these shares are still hosted on our self-managed Windows file servers. DataSync has replicated the data from these shares over to FSx. So, for example, if I look on his existing share, I can see under Documents I have all of these various document names. Now, if I were to go to Amazon FSx, post replication, I can go directly to his share and see that under Documents, all the same exact files exist. Now, if this user were to make a change here, so let's say create a new text document and call it my new text doc, and you wanted these changes to be replicated. If you had those DataSync tasks set on a schedule, it would automatically update it the next time it runs. For now, we're just going to go manually trigger the task to rerun. So I'll choose my user's task because that's the share that is currently hosted on. Say click start and we'll wait for it to finish. The task is now back to available status and has finished. So let's go back to the user. So this is the share, again, that's hosted on the existing file servers where I created the my new text doc. And now if we look over at our FSx share, under the same folder structure, we can see that my new text doc has been replicated. So this is how FSx keeps your shares up to date long term while you wait for your migration to start. Now that I've shown you how the data migration side works, we need to actually migrate to the new shares from the old shares. It is recommended to disconnect SMB clients from the original file server and to ensure that DataSync has replicated all changes. Once we've confirmed data is synced, we can delete the tasks in DataSync to ensure nothing on the source overwrites our target. You may also want to change your existing file shares to read-only to prevent a split brain situation. So we're going to switch over to our administrator that we were performing our configuration on earlier. And we're going to actually connect to our DFS namespace server. Here you can see the share that the user was accessing earlier, afds.com/shares. Underneath this is where we have our namespace targets, dev share and user share. Let's first go to user share. The way to update this is we need to disable our existing target and then add a new target that points to our new FSx file system. So we'll disable this folder target, and then we are going to go add a new folder target. So this will be the share path of our FSx server. Then we'll click OK. We don't need to create a replication group. So you can see here the updated path is our FSx server/users. And we'll do the same thing for our dev share. So now we've also added our developer share path and disabled the original file system. Now that I've updated the folder targets, I'm back on my Amazon Workspace's workstation, logged in with my fake user Aaron Russell. And if you remember, this user gets 2 shares mapped via group policy. Both of these shares were previously located on the 2 file servers that were self-hosted by Acme. Now that we've updated our folder targets to FSx, we should be able to prove that this user is connecting to the same dataset with the same permissions, the same folder structures as before. So if we go here to user share documents, you can see the exact same set of documents. And just to prove that this is indeed the FSx file share, we'll go directly to the file share and make a change. So you can see here, we're on our FSx share. So we'll go into documents again. And why don't we just create a new folder? We'll call it my FSx folder. And you can see in real time that this folder was created, proving that we are indeed now mapped to our FSx file system rather than our self-managed file system. And with that, that concludes the demo on how to deploy, configure, and migrate to Amazon FSx for Windows File Server from existing self-managed Windows file servers. Now that we've gone through the demo, let's summarize everything that has been shown so far. Acme Financial Data Services was able to replace 2 self-managed file servers, which reduced management overhead and increased high availability through the use of Amazon FSx for Windows File Server. Additionally, their existing distributed file system namespace servers were made highly available by adding another instance to a second availability zone. Then, we reused their existing namespace for a transparent migration from a user standpoint. Additionally, CNAMEs were migrated over to the new FSx shares, which allowed any applications or clients to continue accessing without any configuration changes. Lastly, by understanding the usage profile of the shares, cost was optimized through the use of hard drive-based storage. And then additionally, we were able to save on storage used by using deduplication and user quotas. This video is part of the Optimization and Modernization series for Windows on AWS. Don't miss the next in our series. We will show you how EC2 Image Builder will improve Acme Financial Data Services Golden Image Pipeline. Additionally, we have several other videos for you to check out where you can see further optimization of Windows on AWS. This ends our video, and thank you for watching.